one of the ETH India teams that did really well come on and talk about their presentation. I'm not sure, Chinmay doesn't appear to be here yet, but we may have a slot in here where we invite them on to just talk about what they built upon once they're here. So just a heads up about that in case I break the order of presentation.
Yeah, I think maybe they can just go right after Chinmay's wave pool presentation.
Yeah, that sounds good. All right, I'm gonna message Slack and message Matt and we can go.
All right, we're about to go live. Hey, Fiddy, how are you?
Yeah, hey Sam, how you doing? Hey Sunny.
Good.
Hey. All right, just gonna wait for the green light from Matt. We are live. All right. Everyone, welcome to the very first winners presentation for wave pool number 3. We have all the top 3 prize winners for the last November wave pool here on this live stream today. They're going to walk us through what they put together for their wave pool projects, and then we're going to also get some presentations from people who won honorable mention prizes in the last wave and go through the cool stuff they built as well. So without further ado, I'm going to welcome Adam to the stage. Adam, feel free to share your screen and walk us through the really cool borrow against your salary front end that you made for the wave pool in November.
Okay, hello everyone. First, I need to check where can I share the screen.
So on the bottom of your
screen. Okay, I see it now. Okay, can everyone see it?
Yep, we see it.
Okay, so hi, Adam here. I will introduce you our Borrow Against Salary app. First, it's important to note that our application assumes 3 parties: borrower, lender, and employer. I have created 3 separate MetaMask accounts for the purpose of this presentation. So I will log into my account. And first, I will act as a borrower. Here we have a borrower form where we can create a borrow request. We need to specify the amount that we want to borrow. For example, 2,600 DAIs. We need to specify the duration of the loan, let's say 12 months, and the desired interest rate, let's say 10%. Now we have to provide the address of the employer who is paying salary to his employee. So I will switch account, I will switch MetaMask to the employer account. Let's say it would be this account, and I will copy its address and paste it here. Now we will create a borrow request. So let's create one with help of MetaMask. Confirm. And now we will wait for the transactions to confirm. We will see a green snack bar if everything will be fine. When we will create this borrow request, we will we see that our request has succeeded, and we deployed a new smart contract, new borrow smart contract. So now we will go to the employer tab, and we will switch account to the employer. This account was employer. Okay. Now we will send the money to this contract as an employer. So we need to create a flow. Here we see the borrow request that we just made. Let's create a flow to this new contract, and let's say our employee earns 5,000 DAIs per month. We need to confirm the transaction, and we need to wait a little bit. Later, when the transaction will be confirmed, we will be able to change the flow or even delete it. But we need to wait a bit for the transaction to complete. Yeah, our transaction has succeeded. So now we are streaming 5,000 DAIs per month to this smart contract. And at the beginning, everything goes to the borrower, to the employee. He receives everything until the lender decides to lend him this money. So I will switch now to the third account, which will act as a lender. This account will act as a lender, and I will go to the lender tab. We need to wait for the offers to load. Okay, we see our last borrow request. We see that employer is streaming some money there. So now we will lend to the borrower this 2,600 DAIs. Okay, first we have to give permission to access our DAIs. We confirm it, and we will wait for the confirmation. It should be there soon. Then MetaMask will ask us to lend the money to the borrower. We see the profit from the loan and the APR. Oh, something went wrong. I think sometimes an error occurs if this contract, if this borrow contract has no buffer money. So now we will copy this address. This is our borrow contract, and we will stream there some money as an employer, because we need to create a small buffer of money there. Because sometimes an error occurs if there is no buffer in this borrow contract. So we will send some assets to this borrow contract. We will send there, let's say, 1,000 fake DAIs. Confirm. We will wait a little bit. Let's make it faster. Okay, it's confirmed. We will switch accounts to the lender, and we will try again with a small buffer. Okay, we see our borrow request, and we will try to lend the money again with the buffer. I hope everything goes fine. Now we need to wait a little bit. I hope the transaction will come through. Okay, the transaction went through. Now we will confirm that we want to lend this money to the borrower. Confirm. And now we will wait. If everything's go fine, this offer became green. Yeah, everything went fine. We see that we activated this borrow request as a lender. And now we can check that the borrower received this borrow amount. We will switch to the borrower account. which was the first account, and we will see the assets on Etherscan. ERC20 tokens. We see that we have just received 2,600 fake dice, which we have requested in our borrow request. We can see also our request as a borrower. Here we have an indicator that shows us that this is our loan as a borrower. And I think that are the major points of our borrow against salary app. And yeah, I think I have showed you the major functionality of our app. So thank you very much for your time and for your attention.
Adam, that was awesome. Thank you so much for your detailed presentation. That was an excellent flow, just showing us every single piece of the Postal Labs experience. Just a question for you, like,
yeah.
How did you come across Superfluid, and what brought you to get interested in taking on this project?
Our friends that are working in crypto, they show us Superfluid and that you have a hackathon. Then we checked what you have built in Superfluid, and we said it's worth to try it. It's worth to try it, and my colleague Peter, he helped me with your smart contracts because he is a Solidity dev. I'm more web developer, so we worked together. He explained me your smart contracts, and I have connected it with this front end. So together we could build such app, and I think we will try to take part in others hackathons too. So I hope we will build something together later.
Awesome. This was great. Thank you so much. Looking forward to seeing what else you build.
Thanks.
All right. Thank you, Adam. Let's move on to Chinmay, who's going to help us demo Nifty Taps. Chinmay, you here?
Hey everyone, can you hear me?
Yeah, we got you. So Chinmay, I know we discussed actually maybe doing a live demo of this on my very own super token, SunnyX on Polygon mainnet. You ready to tackle that?
Yeah, the issue is I forgot that I require factory approval from the team. I did not get it approved in time.
Oh, the Nifty Tap is a super app that so basically doesn't work right now.
Yeah, so I mean,
Okay.
It works on testnet, but not on mainnet, so I can demo it on testnet.
Oh, that's fine. Yeah, why don't you share your screen and get started? We'd love to see it.
Yep, let me share the screen. Right, is it visible?
Yep, we got it.
Got it. Okay, so let me just. Okay, fine. So yeah, my project is called Nifty Taps, and it's a Wavepool number-free submission. And what it does. So using Nifty Taps, you can claim Superfluid streams based on any NFT position, and these streams can be of any token. So it's not limited to 1 or 2 tokens, right? And so why Nifty Taps? So with Nifty Taps, creators can use the Superfluid streams to incentivize their communities per second. And you don't have to parse the blockchain to weed out the airdrop hunters and so on. And this is much easier than traditional airdrop, in my opinion. So let's see the use cases. So let's say you want to airdrop some social tokens to your Lens profile holders, or else to ENS domain holders, you can do that. And also you can provide a revenue share streams to an NFT collection holders. And something very interesting that I just thought about a couple of hours back is that you can stream fees or even profits to a NFT token holder belonging to a fund. Let's say you want to incentivize pools, liquidity providers, right? On Uniswap V3, you can do that using this. So yeah, so let's move on to the demo. So I am actually going to test in prod. I have not really seen if it works or not yet now, but I do hope it works. So first, what we have to do is that since this is all happening on testnet, I just deployed a mock NFT, and its name is Nifty Taps with the symbol. And you go to the tap wizard contract at this address, right? And just create a new tab, right? And new tab, let's just name it mock tap, and then you give a rate. So this amount you want to stream to claimants per second in like 1 month, right? So this is equivalent to $0.1 per month. So whoever claims a stream from our Nifty tap will receive $0.1 per month. And this is the NFT address, the one that I deployed using Remix. And this is the stream token. So this is something that I created a long time back. It's called Aave USDCX. So the underlying token is Aave USDC, the USDC used in Aave protocol on testnet. So it's just some super token. You can think of it like that. And yeah, so I already executed this transaction, and this tap contract has been created, right? And once you activate the tap, the activation can only happen by the creator of the tap. You can claim any stream. So of course you have to fund this tap. You can fund it using, oops, let me just. Yeah, so you can use Superfluid dashboard and directly send tokens to that tap. And I did that already. Alternatively, you can use MetaMask. So, I mean, if you want, you can just send tokens from here as well, anyhow you like. And once that's done, you just provide the token ID of the NFT that you hold. So I hold the number 0 token ID NFT. Let's see if this works. Let's see, confirm. And let's also see. I think I should go to the original one. So this V1, this might work, but it was better. Let's see if that transaction was successful in the first place. Okay, so it was successful. So am I receiving anything? Yes. So I claimed a stream, and as you can see, I am receiving $0.1 per month. That's what the tap creator, like he deployed the tap using, right? That parameter. So this works. Yeah, and let's see if, wait. Yeah. So that's the demo. So what all needs to happen in the future? So first, actually, we need to build a front end. This was not really easy. As you can see, I did a lot of jumping from one contract to another. So it's not really easy. So our front end for managing taps and making claims easier is the priority. And then one can automate claims of streams using Gelato network. So instead of me going to the website and claiming a stream using my NFT, I can directly get a stream open from Gelato network, and I can, once I get the NFT and I open my Superfluid dashboard, I should be able to see the streams coming in. So that's the end game. And lastly, we can integrate Stroller protocol to earn a yield on idle assets and thereby increasing the tap balance. So Stoller protocol allows you to gain yield on idle assets. So when any creator sends tokens to a tap, that funds just lie over there. So instead, you can give it to Stoller protocol, and it will keep on generating yield for you. And if you are low on balance, if the tap is low on balance, Stoller protocol will top up the tap itself, right? So that increases the tap balance. So these are the three things that we can do, and there are a bunch of other things as well, but these three are the priority. Yeah, thank you. Um, any questions?
Jimmy, that was great. Thank you so much for this detailed presentation. I love like the Canva slide format. And yeah, thanks for the live demo. I could see that really being used for different avenues of community engagement. Just kind of attaching the streams to the NFTs and making them claimable is really cool. Yeah, can't wait to try to get this up and running with my own SunnyX token. So we'll see what we can do. Get that super app registered and make things happen.
Definitely,
All right.
definitely. Thank you.
Yeah. So we can invite Mark to the stage. Mark is going to present his side door streaming API. And yeah, Mark, the 10 minutes is yours.
All right, let me just share. I've got too many windows open, got to find the one to share. Where did it go? I don't know how it's hiding on me. I've got all these windows that are all really dark screens, so I purposely, I must have switched screens. I purposely, there it is. Let's try it now. I'm going to try it again. Oh, am I sharing it? Oh, I am sharing. Yeah?
Yeah,
You
you can
guys
see
see
it.
it? Okay. Yeah, sorry. Okay. Didn't mean to share the whole screen, but this will work. Okay, so side door streams is now I've got the Zoom thing in my way. There we go. Side door streams, the concept is, from quick background, is to provide an API, probably to like Web2 businesses, so they can kind of sort of dip their toes into Web3 things without really asking their users to, jump through hoops and on-ramp and install MetaMask and all that stuff. So the concept is that they could provide a path to their users where perhaps they make payments via credit cards, and then they use this API, which sort of authenticates the users and allows them to do Web3 things. And so this is streaming APIs. There will be, I think, more APIs coming along similar goals. But today, here to talk about streaming APIs, which is the first one. So the concept would be, the flow would normally be that your user would sort of sign up, perhaps make a payment, and then perhaps they don't even have a wallet. So one of the endpoints is this one here, which actually creates a new Gnosis safe. So basically, this API doesn't really accept any parameters. It just, you just send a regular REST request, and it does its thing, and it comes back with the Gnosis safe wallet. Now it's a multi-sig wallet, so that there's 3 owners on this. If initially there'll be 2. There's sort of a side door hot wallet and a side door cold wallet, just kind of as a backup, one that's sort of not connected, right? So there it is. So we can take this address, copy it, and bring it over here. This is on the Goerli testnet. We can see that wallet is connected, and we can see, actually, I've got 3 addresses on this one. If a user already has an address, then they would be added to. So you basically have a shared custody scenario. So they literally have custody of their assets, but if they mess up, side door could step in and fix things. So that's kind of the concept there. Now, next step would be a new user here. I've already got, like, there's the address. Maybe that's the Gnosis safe that we just created. I'm not going to copy and paste the new ones. I'm going to take some few shortcuts here. So we got an address and an email. So this is more Web 2 like. You've got the email. This user already exists. I guess I need to change that email address. Oh, is it the wallet address that's new? Okay, I am going to paste in that wallet address. Okay, so now an email verification would be sent, and it'd be like a one-time password, like a 6-digit number to confirm the email. I'm not going to jump over to show you that. Then there's an endpoint where you would check that, and it would this would give them an API code, an individual user API code once that email has been verified. And the next step is to take that and to create a QR code. So this endpoint takes it really just takes the API key in the authorization and provides this sort of QR code as a base64 image that an app or website or an app could render the QR code. There's also, as you kind of saw briefly there, another one. If you add the format equals image, it'll return the QR code directly, and I can scan it with my Authy or my Google Authenticator app, and that will add that right in there. You won't be able to see me do that now, so I'm not. But if you watch the video that was attached to the submission, I can share that in the chat later. You'll see that part. But I'm going to assume that that's already done, just in the interest of time. And so the next step here per user is setting up a vestor contract. Now, this interfaces with my token vesting contract, which is another project, Superfluid project. It's a manager for Superfluid streams, which enables you to start and stop streams, but also enables you to set an end date. It enables more than one stream per user, per recipient, and a few other things like dropping a one-time cliff payment at the start of a stream and things like that, which could be helpful for teams that want to vest tokens, but it can be used for other things too. It's used by degen dogs for sharing revenue stream. Nifty taps made me think of that. Degen dogs does it in a pretty complicated way, but it's a similar concept is there. So the first step per user, we actually create a vestor contract. So the one-time password I'm going to need this time. So I'm going to my Authy app, I'm copying it, and I'm going to, so if I don't do this, it will fail. And this is a pre-existing, I'm using some pre-existing users and stuff here, so I don't have to show you every single step, otherwise it will go beyond 10 minutes. So this is deploying the contract, and there it is. So it's now deployed using the factory contract for token vesting. The next step would be to deposit. Now I'm not going to use that same vestor. I'm going to use one that I already created, just so again you don't have to watch me copy and paste. But I need another one-time password to do this. Now would be to deposit some funds. Now, do I have? The reason this is going to hopefully work, and it did work, yeah, is because the hot wallet has the funds already, and that would have happened by, say, the user pays by credit card. The company sort of validates that and basically credits them. That's a little bit outside the scope, but that would basically say that, okay, this user has the right to this much sort of FDI, from the hot wallet, and so there's some permissioning that would need to be done there, but that's the reason why this deposit goes from the hot wallet there. So once you have the vestor, you can start a new flow. And so I'm going to get a one-time password here, but this will basically start a stream to from the vestor contract to our chosen recipient. The flow rate, start, duration. So that's sort of the length of it. I think we got 6 months in this example. Lump sum payment is 0 in this case, but we could do one. And there's a reference to sort of give it a label, and we're going to send it to Kramer. So we'll put in Kramer there, and we'll hit send, and that should start the flow. I'm just going to, in the meantime, copy this Vester address. There it is, and that's the response that gives us information about that. If I come over here to the Superfluid console, which is an awesome tool, you should see, or do I have to enable test nets? Yeah, I don't like that feature, guys, by the way. Should be by default. There it is. And so we can see some of the stream. So this should be the stream 27 seconds ago. This is the stream to Kramer. And this user who started this stream, and perhaps a user who's receiving it too, may not have ever, seen a seed phrase in their life, kind of a thing. And that's one of the goals here. So that's that. So there are also list flows. It does exactly what it says. All the flows from this particular Vester contract will be listed here. I'm not going to show these two, but this is like replace flow. It's kind of like a new flow, but it just replaces the existing one. So if you want to change the flow, so basically this doesn't update flow on the Superfluid side, of course. Stop flow will stop the flow. Stop the flow to Kramer in this example. And I won't show those in the interest of time, but that's the basic idea. Obviously, you can probably think of more that go here. I have a few ideas for sort of web apps or even mobile apps that potentially use this, perhaps coming soon to a wave pool near you. We'll see, but that's the basic idea behind Sidedoor.
All right, let's bring them through the side door. I love this. That was really cool, just seeing like how you're able to abstract away the kind of Web3 components to, the transactional experience behind money streams, and really impressive work. And yeah, it would be really cool to see like maybe implemented on like front end or something, or some kind of basic like production implementation. It's really great stuff. So Mark, thanks so much. We can move on to Omnithian from BTFDCA, who is going to talk a bit about his article, which he showed himself reverse engineering the Superfluid governance, allowing for a really cool way to easily test super apps on local mainnet forks.
Hey everyone, let me just share my screen. Yeah, and give you some a little bit of a background.
Hey, it looks like you're muted if you're speaking right now. Omnithian, it looks like you're
Hey, can you hear me now?
all right, you're back. Cool.
Oh yeah, Zoom likes to mute you when you're sharing computer audio. Yeah, I was saying, let me restart. I was saying, yeah, I'm building BTFDCA, and as I'm preparing to launch into mainnet, I was going through, okay, what are the best practices, and before launching, and one of the recommended ones, of course, is to test with a mainnet fork, because while testnets are good and all, at the end of the day, you might have some differences in terms of the target addresses if you're integrating with other protocols. And it's always good to do that with mainnet, but how can you do it without actually deploying to mainnet? Well, that's where mainnet fork comes in. And so I went ahead and, okay, I couldn't find any documentation about how could I do this with Superfluid. So I went around poking and trying to understand how things work. And that's how I came up with this article, and also another article that I'll mention a bit later. So this one is related to mainnet fork. So it explains how you can test your super apps in actual mainnet, but just running it locally. And at the end of the day, it's pretty simple. I'm not going to go into how you do mainnet fork. There's a bunch of articles about that. I'm just going to talk about the specifics with Superfluid. And the specifics with Superfluid is that you just need a registration key to register your super app. Okay, and how do you do that? Well, we can go backwards in how you do that. So starting from our contract and our super app, at some point we're going to have host register app with key, and we're going to have to pass a registration key and the config of our super app. The registration key, it's set out of bounds with the Superfluid team. So before actually going into mainnet, you have to contact the team and say, hey, I want to register my app, and they'll create a key for you. So for mainnet fork, we can reverse engineer that, and the way to do it is going down here is this function here, which is called set. Sorry, yeah. It's this function here, set config on the governance instance. So Superfluid's governance instance, you just do a set config, and we can use things such as impersonate, which is available for mainnet fork. We just have to grab the actual address of the governance, and we get a signer, and with that we can access the government instance, and then we can set the config with whatever value we want for a key, and then with that value we can do the host register app with key. So this article goes into all the details of that, and I also created a GitHub repo that also demos that. You can check out. Then a second article that I also wrote was more related to factories and clones. This is more of a structuring of your super apps and how you have it designed. In my case, my BTF DCA uses factory and uses clones. There's a bunch of advantages to that, and the way you integrate with Superfluid there is a bit different. You don't go back here. You don't have to call host register app with key, where you get a key to your factory that deploys super apps, and then you're just allowed to do that. But the basis is pretty similar. You just have a register app by factory with a config key, and you just need to impersonate, and it works the same way. Same thing here. This article goes into a lot more details, and it also has a repo with an example of how to do things. Yeah, and that's it.
Awesome. Also to be noted is these articles are on Mirror, so you can collect them as NFTs, which is really cool.
Yeah, this is really good. We actually we made a mention of this in our docs actually. So thanks for going through the effort of documenting all this and helping out some of the people in the community. We really appreciate it.
Cool.
Yeah, this was awesome. I literally like took it and just shoved it in our docs, and it's just working fine there. So thanks so much, Tony. All right. So next up we have Umar, the founder of Accountant Quits. He made a really cool article detailing the power of using Superfluid in conjunction with request finance. And Umar, the stage is yours.
Hey, Sonny, can you hear me?
Yeah, you sound fine.
All right, and hey everyone, thanks for having me. So yeah, like you said, I'm the founder of The Accountant Quits. The Accountant Quits is a platform where we speak about the impact of blockchain in accounting and how we can prepare accountants basically for Web3 work. And there's a podcast. I've actually previously had Michele Deliasi, the co-founder of Superfluid, on the show. So yeah, and I didn't know that I was eligible to for a prize, and Sunny reached out to me that I was eligible for to submit the article in the wave pool. So I wrote an article on how to a tutorial article how to stream using stream payments using Superfluid, and how you can create a streaming invoice using request finance. So I thought today I could do a quick demo of how this integration works in request finance. Let me just quickly share my screen. All right, so yeah, this is the podcast page, and this is actually the article that I wrote. on how to stream payments using Superfluid. It's on Mirror, and it's free for anyone to collect if you want. What I did for, can everyone see my screen?
Yeah, we got you.
All right. So everyone's familiar with Superfluid, but Request Finance, in a nutshell, what it is, it's a platform that allows you to, it's a platform for Web3 invoicing, payroll, and expenses. So it allows you to create, to issue an invoice in your local currency and be paid in crypto. So earlier this year, Request had made an announcement of the Superfluid integration, but only last November that the product has been officially live. So you can now start streaming invoices in Request Finance, which uses Superfluid in its backend. For the purposes of this demo, what I will do is I've actually already created an invoice. So I've already created the invoice just for the sake of time, but if I had to create a new invoice, for everyone who's not familiar with Request Finance, I'd create an invoice here, and I go through everything basically in this article. Sorry, just give me a sec. Okay. So it's super simple. You'd have to, you'll start by adding the email of your client. So to allow streaming invoices, currently you would have to denominate your invoice in either DAI-X, USDC-X, or a few other tokens. I'm not sure of everything, but there's not a whole lot of currencies that you can enable streaming right now. So for example, I would have to denominate my invoice, let's say in DAI-X. And currently it's available on Polygon, on Avalanche, and I think on Arbitrum as well. So if I want to get paid, so I selected Polygon, I selected DAI-X as the currency that I would like to receive. I selected my wallet that I would like to receive my streams in. And then you'll have to click on more options and select the first box. I want this invoice to be a recurring invoice paid through a streaming payment. So you would click that, and then you'll have this prompt to select when you want this to be repeated. So there's a few options there, and you would pick a start date and click confirm. You would fill the description, the price, and once everything done, you just click create and send. I already did that, so that's the invoice that I just created for this demo. So what I'm gonna do right now is I'm gonna pay the invoice. So I'm gonna log out of my invoice issuer account, and I'm gonna sign in as the payer. So I sign in as the payer. And something I need to mention, every time you create an invoice, so the payer, either your client or your employer, you will receive an automatic notification and an email that you just received an invoice to pay. So right now, if I click on the sidebar, I click on pay, I would see the invoice, which is awaiting payment. I would click on it. I would click on connect here. I would connect to my MetaMask. So, okay, right now it's saying I have enough super tokens, but you can also always wrap your DAI to your DAI-X. Right now it's saying I have enough super tokens, but I'm gonna deposit here and pay this invoice. So allow permanent, click approve. Sorry, this will take a few seconds. All right, so now I'm gonna deposit. That's why I had created the invoice already, just to save a bit of time. So you can see the message here is the disclaimer message about the buffer risk. So I'm gonna have to tick the box here because all of you guys are familiar with how Superfluid works by design, that streams run till perpetuity. So you'd have to tick this box that you understand this implication and you accept and continue. And now I'm going to start streaming the 3DIX to the invoice issuer. I'm going to click on Pay Now, confirm on my MetaMask, and that's it. So now what I want to show you is what's cool with the request finance is I can actually, your payment is being processed. Okay. So if I go back to my to the issuer account, what's cool is that as a freelancer or as a contractor now, I can actually withdraw my funds at any time, right? So if I log back, if I go back and log in, I will see that this invoice, and right now actually it's still being updated. It's written awaiting payment here, but if we wait like a few seconds or a minute, we will see that the stream is coming in here. So if I click on it, right now the stream has started, but because I've just started it, you still cannot see the number of DIX that has been streamed. But let's see, if I click, if I refresh, you would start seeing this starting to run. I guess it would take a few minutes. Yes. So that's why when I created it, I chose day instead of month. Like I thought it would be a bit faster, but I still cannot see it. Yeah. But basically what I also wanted to say is you would be able to, once you see your DIX coming, you would be able to click this withdrawal button and withdraw your funds at any time. So that's why I think this, this integration of Superfluid with request finance is super helpful for anyone who wants to basically have a compliant way of generating an invoice in streams for basically their bookkeeping at the end of the year.
Awesome, Umar. That was a great presentation. I think it's really cool just seeing this integration, the fact that the financial and the accounting world, they're familiar with monthly invoices and records, but not so much by the second action. And so having this integration that kind of normalizes it into a more digestible thing for financial systems is really cool. So glad to see
I
the
think
demo
it's really
for that.
cool.
Yeah, for sure.
Thank you.
Yeah, thank you. And lastly, we have Fiddy, who's going to talk us through his wave project, which earned an honorable mention prize.
Yeah, hey guys. Just give me a minute to share my screen. Sorry.
We can see it.
Can you see my Visual Studio?
Yep, we got you.
Okay. Yeah, so I'll talk about my project. I just built the contract and the concept around it. So the project itself is called Claimable NFTs. And what it does is that it's a project that can be used by any business out there, just a plugin, and they can use it to actually offer NFTs where people can come later to claim streams. So I may talk a little bit about it. Sorry, I think I opened the wrong one. So the project itself, it allows businesses to actually claim streams using NFTs that they generated earlier. And the first, the application that this project had was around maybe a business that needs to get initial liquidity, not really liquidity, but funds and offer NFTs to maybe lenders that may come later and claim them after the business actually makes some funds. So let me get the project. Sorry. Sorry, I think I had joined with the wrong operating system. Can you give me to switch my system?
See, you need some time.
Yes, 5 minutes.
That's fine. In the meanwhile, Chinmay, would you be ready to just talk about your ETH India project? We can circle back to you, Fetty.
Yep, cool. I'm okay with it.
Awesome.
Am I audible?
Yeah, we got you.
Okay, let me just share my screen. Right, so I hope you're able to see the screen. Just present. Yeah, is it visible?
Yep.
Got it. Right, so hello everyone again. There's our ETH India project called Lens Maxi. ETH India was conducted on December 2nd, like it started on December 2nd and ran for 2 days till December 4th. And me, Fran, and Aditya and SSDD, we built this project, and it's built on top of Lens protocol, Lit protocol, and Superfluid. And we forked Lenster. So I hope you all are familiar with Lenster. It's basically Twitter on Lens. Right. So yeah, the purpose of this project was to create a way to empower content creators to monetize and incentivize and grow the community. And we do this using Lens, Lit, and Superfluid. So how this works is that subscribers of a creator, they stream their money to the creator, and in return, they receive an access to creators' premium content, right? And the subscribers in return receive a stream of social tokens belonging to a creator, which can be staked in a staking contract in order to receive a portion of the creator's revenue. And by allowing subscribers to earn a share of the revenue generated, we believe this aligns both the creator and the subscribers themselves. And so just a brief talk about LIT protocol. So LIT protocol allows us to provide decentralized access control and encryption. So as their website says, using threshold cryptography, LIT provides a key without a key master. So we provide a condition saying that, okay, if anyone has this NFT, they can access a content, encrypted content. And LIT protocol verifies this condition and only then provides a decryption key to decrypt the encrypted content. Right? That's what. And just present again. Right. So how this Lens Maxi works, I already told you. So in the hackathon, we showed a POC where you can stream USDC to your favorite creator and you get access to the encrypted content and also to social tokens that you can again stake and get a share of the creator's revenue. Right. Oh. Right. So there's a diagram which explains the system. So this is a contract where you stream your tokens, right? You don't directly stream USDC to the creators. You stream it to a, let's say, a stream manager, right? And this in turn splits the streams into two streams, one going to the creator himself and another going to a staking contract. And this is a social token belonging to this creator. So once you open a stream, you get the equivalent flow rate worth of social tokens, right? And you can then deposit these social tokens every day to the staking contract, and this is deliberate. We believe that if you come to the website and then click a button to stake your tokens, that will generate more viewership for the posts in general. So that's what. And yep. So once you stake your tokens into staking contract, you are eligible to get 10% of the USDC reward as a reward, right? A portion of 10% basically. And let me just see if this works. So we have a live demo, sorry, recorded demo, and this is what we showed everyone at the venue, at ETH India venue. So let me see if this is visible. Right. Yeah, is this visible to everyone?
Yep, we can see it.
Okay, great. Yep. So this the Lenster website we forked it, and here you are creating a gated post. So when you click premium, so this becomes a gated post, and then you post it. And for that, you have to, as a creator, you do this as a creator, and you send a transaction for the same on Lens protocol. And once that's done, so the backstory is that we had no internet over at ETH India venue, so we had to skip and go forward like this and show to every judge like that. It was a bit tedious. So yeah, so as you can see, we are streaming to Alameda Research, created by Fran. So this how it looks once you open a stream. So someone called Gavin Test is streaming to Alameda Research, and Alameda Research in return is giving social tokens to Gavin Test. So these social tokens entitle the receiver to 10% of the income of Alameda Research, which is none, but still. Right. So once that's done, as you can see, as a subscriber, I can see this post, the dedicated content post. And yeah, so this is just the updates and all happening on the front end. And this is very interesting. You can also see everything on console. I don't know if picture is there. Yeah, so the interesting thing about this contract, the one that I showed as the stream manager, right? So the interesting thing is it never contains any balance of USDC or any token for that matter. And the reason is that we are actually forwarding the tokens, right? We are forwarding the streams to both these entities. So yeah, so based on this work, this is just a plug now. So based on this work, I modified the contracts and everything. And for the next wave pool, my submission will focus on Web3 powered newsletters or even mirror posts. So what I mean is that this system that we created is not just limited to Lens protocol or else, let's say, Lenster, right? We can use it to provide subscription as a service for any gated content. And so next thing that I'm going to do is like, you can see my docs or you can see my posts, my newsletters, only if you subscribe to me using a system that's very similar to LensMaxi. And this can be applied again to Mirror once I create a plugin for that. So you imagine you post a premium content which only your subscribers should be able to see. So that's what is possible later. This is for docs. You can do it for, let's say, videos as well, images, anything literally. And if you use lit protocol, that's even better. It provides the encryption decryption portion of the whole system. So yeah, and that's it. Any questions, any suggestions?
Awesome. Great work, Chimay. I think, yeah, this is really cool. I like the kind of net zero aspect of the super app there. And yeah, I think it's a really interesting layer of like monetization for creators, especially with this growing kind of Web3 social space, being able to, do this incentivization on a continuous basis as opposed to discrete lump sum interactions. Really good stuff. So happy that you had a great time down in India with Fran and your team and came up with a really cool submission at the end. What were the results? Did you guys like win like something from Lens or something?
Oh yeah. So we won the first prize by Lens Protocol. So it was $3,500 for the whole team. And I think going forward, Lenster is going to integrate this in their website. Nothing is finalized yet, but there is a group for that. And by the way, the staking and all that idea, right? Incentivization, it came from Fran and SSDD. So both of them were instrumental for that idea, because before that we were just going for if you subscribe, then you can see the content, and that's quite easy. And probably would not have won as a prize, but yeah. So hats off to both SSDD and Fran.
Awesome. Yeah, it'd be really cool to see you go live. Just imagine having your kind of like little widget up on basically the biggest Web3 social application. So cool stuff. So thanks, Chimay. I think we can move on to Fiddy if you're ready.
Yes, sorry for the delay.
That's fine.
Let me share my screen. I hope you guys can see my Visual Studio.
Yeah, we got it.
Okay, so I'll go through the tests I wrote for this contract. I actually just wrote the contract as a concept, and I'll start by going through the theory I was trying to prove. So NFTs that give claim to a stream. This project actually tries to showcase how you can use NFTs to let people actually come and claim a stream based on an activity they interacted with your contract previously. So with this hypothesis, it was a business that operates on chain, let's say a DAO or any other business at that, and interacts with stakeholders like creditors, freelancers, and customers at large. So this business, in a business setting, normally you require credit sometimes to fund your activities, maybe if you don't have enough cash flow with you. And this project actually provides a business a way to actually manage its day-to-day activities using NFTs that can come and be claimed later. And by this, I mean NFTs that give people like, let's say, employees or a freelancer working with that business, or even someone trying to lend funds to that business to come later and claim a stream based on the NFT they generated when actually giving their service to the business. So the assumptions here was that this business is fully on chain, and it pays its employees in streams, pays its debts also in streams, but receives cash flows also in streams and through normal ERC20 transfers. So I'll try to take you guys through the tests I wrote for the project, which actually takes us through the whole procedure of operations on this contract. So first, I'll start by where we initialize the business contract and the NFT initializer that actually provides NFTs to that business contract to distribute to different stakeholders, whereby if you transfer funds using a normal ERC20 transfer, you're going to claim a different NFT with someone actually providing funds or who wants to receive funds in a stream, or someone actually providing credit service through credit receives a different type of stream. So there are different NFTs offered by this contract that offers you a claim to a specific position later on in time. So the workflow basically requires the business to actually broadcast. Sorry, I'll go to where it's testing the business. And here we initialize NFT contracts, which will just add the NFTs on the business and add assets that are going to be required by the business, either through payment or lending. After that, we are going to try and broadcast credit. So this broadcast credit is a function that allows the business to actually tell the general public that we need maybe these funds or this service at credit, then we'll offer you an NFT and you can come to our contract and claim a stream at a specific date. And as you can see from the credit broadcast information, there is the asset which they're broadcasting to borrow from. Transferables is the amount that can get transferred for that particular broadcast. The flow rate is the maximum flow rate required by the business at that point, maybe as a credit. And the duration is how much this broadcast should last, and also how much it's going to be paid. And each broadcast comes with a custom interest strategy that actually makes different broadcasts pay out different rates. So it gives the business an opportunity to actually maybe offer different interest to different stakeholders, trying to offer them upfront cash or liquidity for their day-to-day services. So after the broadcast is made, you as someone who is interested to do business with that contract can actually now come and start interacting with it in the form of lending to the business, which actually just transfers a certain amount to that business and actually gives you an ID. And as you can see, this function actually returns an ID that for an NFT that gets minted to you after you, for an NFT that gets minted to you after you actually lend those funds to the business. This is the function I'm speaking about. And as you can see here, it mints you an NFT. Sorry, let me show you. Yeah, this ID is the ID of the NFT that gets minted to you, which is mint a transfer NFT to the sender. So you offer that funds up front, get an NFT, which gives you the ability to come and claim a stream based on the NFT you needed and the flow rate you actually need to be paid in later on when the duration of the broadcast is up. So there are several ways people can actually lend to this business, and one of them was just this lending. The other one occurs through a stream, whereby if you open a stream to this contract, there's a callback that actually gets seen and also means you an NFT. Here we go. Yes, also means you an NFT, which you can come and claim later after the broadcast that you are actually streaming to actually ends. So I'll go back to the tests, which actually show this in real. And right here, we were trying to test lending to that business using a stream. Here's the user data, the flow rate we are going to be offering, and actually calling the host with a stream to that. So I'll run the test, and as you can see, we are ascertaining at every point that whatever action you're trying to call is actually happening in real time. So that is the second way a user can interact with it. And the third way is actually where you are offering a service that cannot be tracked on chain. So the business actually gives you an NFT that you can come and claim later for the services you offered. And this is where a business can use this to offer NFTs to, let's say, freelancers, people who they have a contract with and they want to pay them at a later date using a stream. So they offer you an NFT using this give claimable NFT to a creditor who is someone who offered a service to the business. And after that, the creditor also gets a unique NFT that they can come later and claim their funds with. So since I needed to do this on my local machine, I had to manipulate the local development environment a little bit to actually pass the blockchain to 90 days and also to increase the block number so that we can actually come and do some other things that are needed. And this one was actually used to delete the flow that we were talking about here, which means it also deletes the NFT, it bans the NFT that was issued to you if you delete the flow. No, not deletes it, but you need to delete the flow after the broadcast period has ended before you can claim your stream based on the NFT you had. So I'm just going to show one instance where we try to claim a stream. And here we are trying to claim this stream with the ID, which is the ID of the stream lender, the person who offered funds or liquidity to the contract using a stream, the stream lender here. So we claim a stream and try to see if that runs. So we also claimed the stream to the person who offered with a transfer. And currently, that's all we tested for now, just to ascertain that someone can actually come in. The business can broadcast a position where they need money. Someone comes in, offers that position through a transfer or through a stream. After the 90 days or the period for the broadcast has ended, they come back and actually claim the stream, which creates a stream to the address that is actually linked to that NFT. Sorry, let me show just a little bit about the claim stream function. Yeah, so here's the claim transfer stream. And as you can see, it's specific to a user who offered a cash flow to the contract through a transfer. And as you can see, it creates a stream to the person claiming with the flow rate based on the flow rates they needed to be paid in, which should be actually covered by the contract. So I'm going to run, sorry, I had already run the tests, but I'm just going to rerun them just to show that the workflow with the full logic for the contract actually works. I think it's going to take some time. Yeah, so as you can see, all the tests that came in passed. meaning that this project can actually be used by any project out there as a plug and pull to get liquidity and also pay people at a later date who come to claim whatever position they had using an NFT and get paid in stream. Thank you. I think that was my project for this wave pool, and I'm really glad that I received an honorable mention.
Yeah, great work, Biddy. Kind of reminds me of like a credit card NFT where you're kind of claiming credit in the form of a stream. Yeah, really great work there. Really kind of cool engineering, especially with the Foundry side where you kind of got in there and we're able to simulate transaction pattern, which is really impressive that you figured that out. So great stuff, and love to see it. Anyway, guys, that concludes our live stream here on the winners of our November wave pool. The December wave pool is starting up already. It's in action. You can work on projects and submit them by the end of December, and you'll be put in the running for prizes for this December wave pool, which has the same prizes as last month's 2,000, 1,500. And then 1,000 as well as the pool prize for honorable mention. So everyone, thanks for coming out today and checking out our winners and the cool stuff that they built, and hope to see you at the next live stream. Cheers, guys.